Hey there! This is the first video in our RAG series, and I'm really excited to kick things off. Over the next few episodes, we're going to explore Retrieval-Augmented Generation, or RAG for short. We'll start by getting a feel for what RAG is. Once we've got that intuition down, we'll dive into the research paper that introduced RAG, break it down in a simple and clear way, and then later on, we'll actually try to build RAG from scratch. So whether you're curious about how RAG works under the hood, or you want to see it in action with code, this series is for you. Let's jump in. AI is getting really smart these days, especially with how advanced large language models have become. Models like Llama, ChatGPT, and Google's Gemini have evolved rapidly. They can't exactly think like humans, but they mimic reasoning surprisingly well, almost to the point where it feels like they do. But that's a whole other topic, and we'll save it for another video. But sometimes, even the smartest brains, like this one, get confused. Yup. Language models can hallucinate, make stuff up. They seems to entangle in their own process and provides random responses. But we have a fix, introducing RAG, Retrieval-Augmented Generation. It was introduced in 2021 by a paper published by Facebook AI Research. Now, we talking about RAG, and a common question is, what is RAG? Let's try to understand this from the difference between traditional language model and RAG model. Traditional language model answers questions purely from memory. Here memory means the data used for training. Whereas RAG model checks the book first, and here the book means updated information before answering. Which means smarter and more accurate answers based on the updated data. Now we will dive deeper in its architecture to see how it works. There's an image shown on your screen of the RAG architecture. Step 1, User Question. Step 2, Retrieve. A RAG system searches external knowledge. It pulls out the most relevant snippets. Step 3, Augment. It then combines those snippets with your question. Step 4, Generate. And sends it to the model to generate an informed answer. So, RAG isn't just memory, it's fact-based generation. It's about understanding what you asked, going out, finding real information, and then using that to build an answer that makes sense. Whereas traditional language models try to recall everything from their training data. Let's quickly go over the main components of the RAG architecture. First, we have the query. This is the initial prompt or question that the user asks. It's what starts the whole process. Next is the retriever. Its job is to go into a document database and pull out the top K most relevant pieces of information, based on how similar they are to the query. It does this using similarity search, which we'll explore more in the next section. Think of the retriever like a built-in search engine for your model. Then comes the generator, which is the language model. It takes both the original query and the retrieved documents, and generates a final answer. So while the retriever searches for the best supporting information, the generator uses that info to write a grounded, relevant response. In short, the retriever finds the facts. The generator writes the answer. Together, they make RAG powerful, flexible, and far more accurate than models that just rely on training data. The next question that pops in is, why use RAG? Let's try to understand it. Benefits of RAG. Benefit 1, up-to-date and accurate. Traditional language models freezes in time. It mainly depends on its training data, which can be outdated. Suppose the model is trained on 2022 may lacks the information of 2025, but with RAG you can connect to current information. You just need to update the data source and there you go. And most important, it helps reduce hallucinations. Benefit 2, access to proprietary data. Want answers from your docs? RAG makes it possible. Securely. With RAG you will get answers from your docs and no concern for security. Benefit 3, explainability and trust. You can trace the source of any answer. Benefit 4, cost-effective updates. Retraining big language models is expensive. But with RAG you just need to update the docs or say the data source. Is RAG still relevant? With models like Gemini 2.5 Pro, which has millions of tokens, this means it can now digest entire books in one go. We're talking millions of words at once. So is RAG even still necessary? Yes, it absolutely is. Here's why. Even though today's models can handle millions of tokens, finding the right piece of information in that huge chunk of context is like finding a needle in a haystack, with a matchstick for light. Not only is it inefficient, but there's also the issue of cost and latency. Feeding massive amounts of context to a model increases compute time and expenses, and still doesn't guarantee accurate results. RAG solves this. It's more targeted, more accurate, and better when your priority is verifiable information. Rather than throwing the whole haystack at the model, RAG retrieves only what's relevant, keeping the process fast and focused. Plus, it's more secure and reliable, especially when working with private or proprietary data. And there's one more important point. RAG allows dynamic and scalable access to vast amounts of data, far beyond what can fit into a model's context window. You're not limited by token limits, you can plug into entire databases, document collections, or even live APIs. That kind of flexibility is powerful. But here's the real takeaway. The winner isn't RAG versus long context models, it's a hybrid approach. By combining the breadth and dynamic access of RAG with the depth of long context understanding, we can build systems that are both accurate and intelligent, grounded and fluent, the best of both worlds. So even with giant context windows, RAG still plays a critical role in building smart, efficient, and trustworthy AI systems. And RAG is still evolving. RAG today isn't just one thing anymore, it's a whole family of techniques. Researchers and developers have pushed the boundaries, making RAG faster, smarter, and more adaptable. Let's get into the mathematical intuitions. A peek into the mathematics behind RAG. Embeddings. Text is turned into numbers, vectors. Similar meanings equals close numbers in vector space. The word cat and kitten, when plotted, they lie closer to each other, which means they are semantically similar to each other. Vector database and similarity search. These vectors go into a vector DB. When you ask something, it's turned into a query vector. The system finds nearby vectors, like finding close angles. Which is cosine underscore similarity. The formula is shown on the screen. The augmented prompt. Then RAG merges the original query plus top documents and sends them to the language model for generation. Now the model has the top K retrieved documents along with the original query. And with the exact information in question, the model can generate an accurate answer. Time for a recap. The key points of this video are visible on the screen. See you again. Stay tuned.